Our universe is constantly expanding, which makes it incredibly difficult to determine its boundaries or accurately measure its full size. However, with the remarkable capabilities of the James Webb Space Telescope, humanity is now able to peer into the farthest and most ancient corners of the cosmos. Since the launch of the James Webb Telescope, numerous scientists, including renowned physicist Brian Cox, have made groundbreaking announcements about the true scale and vastness of the universe, a magnitude that is nearly impossible to fathom. Within the portion of the universe we are currently able to observe, there are estimated to be around 2 trillion galaxies. This number is based on detailed studies of our local universe. However, scientists are confident that what we can see is only a tiny fragment of the possibly infinite cosmos that lies beyond our reach. Importantly, we are not separate from the universe. We are an integral part of it. In a poetic sense, we are the means through which the universe has come to know itself. With the continued exploration made possible by the James Webb Telescope, we are embarking on a journey to discover the true scale and composition of our universe. If you are fascinated by these discoveries and wish to stay informed about the cosmos and everything beyond our planet, we invite you to subscribe to our channel. Be sure to like this video and turn on the notification bell so you never miss a new update. To grasp the immense scale of even our own solar system, consider this. If we traveled at a constant speed of 70 miles per hour, it would take about 15 days to complete a single lap around Earth's equator. At that same speed, it would take around 5 months to reach the Moon, 63 years to get to Mars at its closest point, and a staggering 4,400 years to arrive at Neptune. These travel times underscore just how vast our solar system truly is. For further context, take Voyager 1, launched in 1977, which travels at a speed of 38,000 miles per hour. It didn't leave our solar system until 2012, which means it took 35 years just to cross that boundary. Even light, which can circle the Earth 7 times in a single second, seems almost sluggish when compared to the immense distances of space. And yet our vast solar system is just a tiny speck when placed within the Milky Way galaxy. The Milky Way contains approximately 300 billion stars, each likely accompanied by its own planetary system. The closest star system to us, Alpha Centauri, is 4.3 light-years away. Even traveling at the speed of light, it would take over 4 years to get there. Now imagine trying to reach Alpha Centauri using the same speed as the Voyager probe. At 38,000 km/h, it would take about 70,000 years. These numbers reflect the staggering scale and isolation of star systems across the cosmos. Let's now consider Betelgeuse, likely meant instead of Volta Rouge, a star located roughly 640 light-years from Earth. This means that the light we see from it tonight actually began its journey to us 640 years ago, around a century before Christopher Columbus set sail for the New World. That light has traveled all this time through space to finally reach our eyes today. Despite this immense distance, Betelgeuse is still relatively close in astronomical terms. Equally fascinating is our radiosphere, the region of space that our radio transmissions have reached since we began broadcasting about a century ago. While these signals degrade significantly over distance, they have now reached roughly 15,000 star systems. However, this is only a minuscule fraction of the hundreds of billions of stars in the Milky Way. To visualize this, imagine if our solar system were reduced to the size of a coin placed on a map of the United States. The entire Milky Way would then span the size of the actual continent. In that vast region, there would be around 300 billion star systems, and we are just one of them, adrift in a sea of unimaginable scale. Beyond the Milky Way lie at least 1 trillion more galaxies. To grasp the enormity of this number, imagine a collection of 1,000 cats. Now picture 1,000 groups of 1,000 cats. This gives you 1 million cats. To reach 1 trillion, you would need 1 million groups of 1 million cats each. That's how vast 1 trillion truly is. Our nearest neighboring galaxy, Andromeda, is located 2.5 million light-years away and is approaching us at a high velocity. As it draws nearer, our night sky will undergo dramatic transformations. Andromeda contains about 1 trillion stars, and when it eventually collides with our own galaxy, home to 300 billion stars, the likelihood of individual stars crashing into each other remains incredibly small. This highlights the immense distances between stars, even within galaxies. Paradoxically, galactic collisions, though chaotic, can spark the formation of new stars and may even promote the conditions necessary for life. Galaxies themselves are not static. They are dynamic systems that evolve, collide, and grow. Beyond the Milky Way lies the local group of galaxies, which includes Andromeda and about 80 other galaxies. This group is part of a much larger collection known as the Virgo cluster, which contains over 1,500 galaxies. Virgo in turn belongs to an even grander structure, the Laniakea supercluster. This supercluster is home to approximately 100,000 galaxies, each brimming with hundreds of billions of stars and planets. And yet, even this is only a small part of the big picture. Within the observable universe, scientists estimate the existence of about 10 million similar superclusters. As we zoom out, we discover an increasing number of mapped galaxies, though these represent only a tiny fraction of what exists. Hundreds of billions of galaxies remain uncharted, waiting to be discovered. Another key piece of the cosmic puzzle is the cosmic microwave background radiation, the faint glow left over from the Big Bang. This relic radiation is the oldest detectable light in the universe and offers a snapshot of the early cosmos, serving as crucial evidence of its origins. Moving beyond galaxies, we encounter vast regions of space called cosmic voids. These are immense, mostly empty areas spanning hundreds of millions of light-years across. Though they appear barren, cosmic voids are thought to have the potential to give rise to new cosmic structures over time. Binding the universe together are cosmic filaments, enormous threads of gas, dust, and dark matter that stretch across billions of light-years. These filaments form a web-like structure that links galaxies and clusters into an intricate cosmic network. The universe's matter is not evenly distributed. Instead, it forms this delicate web of filaments and nodes where gravity gathers galaxies together. Within this immense and evolving cosmic stage, we find extraordinary phenomena like supernova, the explosive deaths of massive stars. These events scatter essential heavy elements across space, enriching future planetary systems. Black holes, with their powerful gravitational pull, shape the evolution of galaxies and release tremendous jets of energy. Quasars, or supermassive black holes actively consuming matter, emit colossal amounts of energy and serve as beacons from the early universe, allowing astronomers to study its primordial phases. All of this raises an awe-inspiring question. What lies beyond the observable universe? There are surely many galaxies that exist outside our ability to detect them, simply because their light hasn't had enough time to reach Earth. Moreover, because the universe is continually expanding and galaxies are moving away from us, most of their light may never reach us at all. These unreachable regions may remain forever invisible. However, based on current physics and cosmology, we can make educated inferences. These suggest that the entire universe is at least 250 times larger than what we can observe. In fact, some theories propose that the universe may be infinite in size. In light of this, we are invited to reflect on the nature of our existence. We as human beings on a small, fragile planet, in a vast and ancient cosmos, are left to ponder our place in this grand narrative. The scale of the universe is not only humbling, but also profoundly inspiring. Have you ever wondered just how vast our universe truly is? If so, we hope this exploration has helped you better understand the sheer immensity of the cosmos. Please feel free to leave your questions in the comment section. If you enjoyed this content, give it a like, share it with others, and subscribe so you won't miss out on more videos like this. Thank you for watching, and we'll see you in the next one.